Hello everyone, welcome to the learning field. This is Chandan, and in this video, I will discuss the questions of CSIR Net December 2024 that held on 27th of February 2025, Linear Algebra Part B. So here total 1, 2, 3, 4, 5 and 6 questions from part B and into 3 marks, that is total 18 marks came in this paper. So let's start to solve the questions because we know that session net will hold on 18th of December 2025. So practice is very important. So I'll try to provide from now continuously the question solving or previous year solutions video with a very nice approach. So, and if you need anything for your upcoming CSR net exam, then you can definitely comment. Also, for part A, that is the general aptitude portion, I already solved the PYQs papers of most of the papers of CSR net that you can get in a separate playlist for CSIR net part A solution. So I have a playlist on my channel, so you can visit this playlist to solve the PIQs of part A also. And now I'll start from here the CSI net December 2024, that is already on 27th of February, linear algebra part B solution. So let's start. So the first question is here. What is the question? The question says that let U denote the span of this in the real vector space of continuous functions from R to R. Uh, Consider the R vector spaces, that is the real vector spaces. V equal to what is given? V equal to, change the color, black or okay or red is okay. This color I take. So V equal to what is given? V equal to F such that U to R. This is a vector space is given, or F is a linear transformation, and W equal to what is given? W equal to F belongs to V such that F of exponential 3D equal to 0. Now, what is U? U is a span of e to the power t, e to the power 2t, and e to the power 3t. And we know that these three quantity are linearly independent. That means what is the dimension of u? This is the basis of u. Okay, this is the basis of u. So dimension of u means this is equal to clearly 3. Now, what is the dimension of v? What is v actually? So if U has dimension 3, then V is actually what? The U star. What is U star? U star is dual space of U. This is the actually definition of dual space of U. And we know from the fundamental theorem of linear algebra is that dimension of U equal to dimension of U star. That means dimension of V equal to again 3 we get. So now, what is the dimension of B? Dimension of B equal to 3. So option 1 says that both infinite dimension, we can discard this one. B is infinite dimension, we can discard this one. So dim B equal to 3 and dim B equal to 3 both are given. Now W equal to, given that f of e to the power 3t equal to 0 and f of 3 e to the power 3t, this is a condition and which is a actually linearly independent restriction that we say in linear algebra restriction. So linearly independent restriction, that means dimension of W equal to what? Dimension of V minus 1, that means 3 minus 1, this is equal to 2. So which option is true here? Option C is true here. Dimension of V equal to 3 and dimension of W equal to 2. Option 2 is also discorrect or incorrect. Next question. So it is given that let A be a matrix this, and where ABC are real numbers with ABC equal to 1. Now, if B equal to this, then which of the following statements are true? So, A, B, C are real numbers. Okay. And if A, B, C equal to 1, so two cases may occur. Case 1, which is that A, B, C equal to, if we take 1 omega square, then ABC means omega cube, this is equal to 1, but this omega and omega square are complex, but here says that ABC are real. So the easy case to solve this problem, we choose the ABC real number. So the most easy form of ABC is A equal to B equal to C equal to 1. If we choose this, because there is no restriction on choosing ABC, just they said that ABC are three reals. So if ABC equal to 1, then the matrix A equal to what? 0 1 0 0 0 1 and 1 0 0. Now, what is the eigenvalues of A? So row sum equal to 1 or column sum row sum equal to 1. So 1 is one eigenvalue. The next eigenvalue we have to find. Fine. So now what is the eigenvalues of A, B and C? So here the case I say here 1 omega square. Instead, this is a real matrix. The eigenvalues of this matrix may be complex. So, possibilities of the eigenvalues, if we choose omega and omega square, these two eigenvalues, so you can definitely also find the eigenvalues of this matrix 0 1 0 0 0 1 and 1 0 0. 1 omega square will be the eigenvalues of A. You can definitely check once if you want. Okay. Now, if 1 omega square are the eigenvalues of A, then what are the eigenvalues of B? So, eigenvalues of B are one first eigenvalue is 1 plus 1 square plus 1 cube, which is equal to 3. Next eigenvalue is omega plus omega square plus omega cube. And we know that 1 plus omega square equal to what? 0. And here omega q equal to 1, that means this eigenvalue is 0. And another one is also omega square plus omega to the power 4 plus omega to the power 6. That means omega plus omega to the power 4 means again omega, and omega to the power 6 means, oh sorry, this is omega square, omega plus omega to the power 6 means 1, this is again 0. So the eigenvalues of this matrix B is 3 0 0, and if 1 is non-zero eigenvalue, that means rank of this matrix B, this is equal to 1, and the eigenvalues of B square equal to 900. So eigen rank of B square equal to what? Rank of B square equal to 1 non-zero eigenvalue, and date of B equal to what? Date of B. Date of B equal to 1 into omega square. That means omega cube, which is equal to 1. So that means uh, date of B means, oh sorry, date of B means 3 into 0 into 0. 3 into 0 into 0, that means 0. So date of B is 1 says here no. Date of A equal to 1. 1 omega square. Date of A equal to what? 1 into omega square, which is equal to omega q equal to 1. Fine. So this is also incorrect. Rank of B equal to 1, incorrect. Rank of B square equal to 1. This is correct option of this problem. Fine. So you can say me that how you guess. Actually, this in this problem, one is one eigenvalue and another eigenvalue of this matrix. You definitely can consider also this is like an that matrix I name forget the name, that is the component matrix type, that type of matrix one name. So you can also find, since this is only 0 and 1, So you can also, I think, companion matrix. Also find from the directly write the characteristic polynomial and find the I think matrix. Find the rank. Okay. Uh, Now the next one, or you can definitely check by the general rule. Next is this question. Question number, question ID is 704109. It says that for a variable x, consider R the vector space V equal to A0 plus A1x plus A2x square, where A0, A1, A2 belongs to R. Let T from V to B be a linear transformation defined by TF equal to what? TF equal to A plus BF BX. Now, for simplicity, we can choose the V. This is equal to 1 plus x square. Fine. Since only A0, A1, A2 belongs to R, there is no restriction. Then, for simplicity, we can choose this A0 equal to A1 equal to A2 equal to 1 for simplicity. Fine. So what will be the T of 1? So T of 1 equal to, this is 1 plus 0, that is 1. T of x equal to 1 plus 1 is equal to 2, and T of x square equal to uh, T of x equal to x plus 1, and T of x square equal to x square plus 2x. Now if we write the matrix form of this linear transformation, suppose A is the matrix form of the linear transformation, then 1 x square na. So 1 0, coefficient of 1 is 1, then a coefficient of x is 0 and 0, then x plus 1 is 1 1 0, then x square means 0 uh, 2 and 1. Now this is clearly a upper triangular matrix, upper triangular, and the easily we can say the eigenvalues. Eigenvalues are, eigenvalues of A are 1, 1 and 1. Fine. Now what is the eigenvalue of this TQ minus 3t square minus 3t? So eigenvalues of TQ minus 3t square minus 3t plus 3t. So the eigenvalues of these are 1 cube minus 3 into 1 square plus 3, which is equal to 1, and similarly for the others. That means 1 1 1 are again the three eigenvalues of this. Fine. TQ minus 3t. So then what is the eigenvalues of PQ minus 3t square plus 3t to the power 2025? This means 1 to the power 2025, which is equal to again 1. So now 1 means what? Again 1, 1 and 1. That means these three eigenvalues are again 1, 1, 1, which corresponds. So these two also option we can definitely cancel. And now this into operating of x. So this on x equal to x given na, and eigenvalues of 1, only this case is happen when eigenvalue is equal to 1. X plus 1 is not happen. Okay. So this is suppose a matrix whose eigenvalue equal to, suppose we know that a x equal to lambda x na. So suppose this matrix equal to A. So A into x, this is equal to what into x? Eigenvalue is 1, 1 into x. This is only happen. Other, because three eigenvalues of 1, 1, 1. So here we can put the lambda 1, lambda 2 or lambda 3. Okay, equal to x. That means only option 1 is correct answer. Next question. Question says that let V be the R vector space of 5 by 5 real matrices. So V is a 5 by 5 real matrices. So what is the dimension of V? Dimension of V equal to 25. Let S equal to AB minus BA, such that AB belongs to matrix V. So AB is also a 25 by 25, 25 by 25. That means S is again a matrix of 25 by 25. So let W be denote the subspace of B spanned by S. Fine. So W is a subspace of B spanned by S. Let T from V to B be a linear transformation, linear mapping of a matrix A is its trace. So this line is important. So trace T is a linear transformation from V to R. V to R given by what? Such that trace of this matrix its trace. That means be a linear transformation V to R. Trace of this AB minus BA and its trace, and we all know that this trace of AB means trace of AB minus trace of BA, which is equal to 0. Fine. So what is the dimension of uh, V? V is dimension of 25. Fine. And so this is W. Okay. E from VBA subspace of V. VBA subspace W denote the subspace of V na. So if W is a subspace of V with one condition, then what is dimension of uh, W? So dimension of W equal to 24, and dimension of now V is this. So what is the and T? What is the dimension of T? And this is dimension 1. So dimension of we know that what dimension of domain equal to nullity plus dimension of what this R, the code dimension of domain by rank nullity theorem. Okay, so dimension of domain nullity means we have to find the nullity here. Dimension of domain means here is 25 and this dimension is 1. That means what is the nullity? Nullity equal to 24 again. So that means what is the dimension of kernel of T? This is 24 and dimension of W is equal to also 24. That means this W equal to cut T will be the correct option. Okay. Hmm. Fine. This is the correct option. And you can say that how this dimension equal to 1, since R is a matrix V to R na. So it's a matrix which is equal to 1 by 25. Fine. This is a matrix 1 by 25 and rank equal to what? Rank equal to minimum of number of row, number of column. This is 1. Fine. 1 comma 25 which is equal to 1. So this answer is 24. Sorry, option is 1. Now option T1 says that let V from ABC B equal to ABC belongs to R3 be a non-zero vectors lies is the orthogonal complement with respect to the standard inner product of the with the row space. So this is a matrix. This is a row space. These are the row. That means row space of the matrix. If ABC are all integers, then what is the smallest possible value of ABC? So here given A dot V, this is equal to 0 because these two are orthogonal to each other. So A dot V equal to 0 means 2, 2, 7, 3, 1, 4 and A, B, C. This is equal to 0, 0. That means two condition we have 2A plus 2B plus 7C. This is equal to 0 and 3a plus b plus 4c. This is equal to 0. Now from here, what is the value of b? B equal to minus half into 2a plus 7c. And from here, b equal to minus of 3a plus 4c. If we equate this to b, then half 2a plus 7c, this is equal to 3a plus 4c. That means 2a plus 7c is equal to 6a plus 8c. Now 4a equal to minus of c. Fine. Now we can write, since here says that a, b, c and all integers. So we write this form first, non-integer form, which is a equal to minus c by 4. Fine. So a equal to, we get minus c by 4. So what is the minimum value of c, for which a is an integer? So minimum value of c is equal to 4. So if c equal to 4, that means this is the value of c. Okay. Uh, yes. Therefore, a equal to what? A equal to minus 1 definitely. If minimum value of c equal to 4, then minimum value of a equal to minus 1. Now, put any of this equation, we get minimum value of b. Till this is minimum. Minimum value of b equal to what? B equal to minus 3a means 3 plus 4c means 16, which is equal to minus of 13. Now, a plus b plus c equal to minus 1 minus 13 plus 4 is equal to minus of 10. If we give here the modulus, then the value is 10. Option 2 is true. Next question says that consider the bilinear form b equal to r4 cross r4 to r defined by bxy equal to this one. So we write the matrix first. Suppose A is the matrix of the bilinear transformation. This is a 4 by 4 matrix definitely. So x1 x, suppose this is x1 x2 x3 x4 y1 y2 y3 y4. So x1 y3 means this constant is 1, remaining are 0. x2 y4 means this is 1, the remaining are 0. Then x3 y1, this is minus 1 0 0 0, and x4 y2 minus 1 0 0 0. So this is the matrix form of this bilinear transformation. Let A denote the matrix of B with respect to the standard ordered basis of R4. Which of the following statements of R is true? Det A equal to 0. What is the det A? Actually, we can say that this is a block matrix. We can definitely uh, find the block. So first one block is 1 0 0 1, and two eigenvalues are 1 and 1, and from this block the minus 1 0 0 minus 1, the two eigenvalues are minus 1 minus 1. That means date of A equal to product of this 4, which is equal to 1. So option A, B are not correct. Now bxx is not equal to 0. So first find the bxx for all non-zero x equal to 0. What is the correct option? bxx. So if we first find the bxx, so x equal to, if we take x1 x2 x3 x4, then bxxx equal to, that means y will be changed by the elements of x, that is x1 x3 plus x2 x4 minus x3 x1 minus x4 x2. See, you can say this x1 x3 and x3 x1 are cancel out, and these two terms are cancelled out, but this may not be true. because this is a bilinear transformation. In all the cases, the matrix may not be a symmetric matrix. Okay, if this is a quadratic form, in that case the matrix will be a symmetric matrix. But because of these two term are alternate, means symmetric position holds these two terms, you can say that, but these may not hold in the case of bilinear transformation. Now all non-zero for all x belongs to R4. So if we choose any x for which these will 0 or not. So if we choose any type of vector like 0, 0, 0 and 1, then what happen? X1, X3 means 0, X2, X4 means 0, X3, X1 means 0, X4, X2 means 0. So choose any three element 0 and any one element is non-zero, then you will definitely get a 0. And this is a non-zero vector, but for a non-zero vector we get this is equal to complete 0. So this option is also incorrect one. That means the option 4 is the correct one. If x belongs to R4 is non-zero, then there exists y belongs to R4 such that bxy is equal to non-zero. So for if any non-zero exists, then there exists. But here it says for all. So for all this may not hold, but for any non-zero vectors that may be non-zero. So this option is correct option. So these are the 6 questions of linear algebra part B. Linear algebra part B. So if this video is helpful, then definitely give a like to this video, share with your friends, and subscribe the channel. Forget to get more videos like that. So I know that I didn't make any videos like 50 days. I do not upload any videos in previous 48 days actually, because I have some exams and presentations for my PhD, so that I was a little bit busy. But I'll try to continue definitely uh, to the to this channel, and I also think about some talkative sessions, with some of my friends and seniors who currently doing their PhD in different fields actually. Okay, different fields. So you can comment me that if this talkative session is helpful for you, because if I make the session here here in the YouTube live, and we try to give it live, so that you also can actually avail different fields of PhD, different works you want to know, or you definitely know the different fields, what types of work actually you have to do, what type of work in your interest, not interested. So this type of session actually I want to make, that I previously make 3 or 4 session like that, 3 or 4 session like that. So I will continue this session, talkative session. Actually, there are different branches of mathematics who actually complete or pursuing their PhD. So I want to make this discussion session or talkative session like that. So what will your opinion? Definitely comment in the comment section below. Okay, thank you. मिलते हैं इन्हीं अगला वीडियो में।